Hey, this is our first lesson about initialization, which is a crucial part of machine learning. When you use clumsy or inappropriate methods, even the fastest computer in the world won't be able to help you. As they say, the devil's in the detail, and this saying is as true as it gets for initialization. Okay. Initialization is the process in which we set the initial values of weights. It was important to add to this section to the course, as an inappropriate initialization would cause an unoptimizable model. Let's revise what we have seen so far. When we introduce the simplest gradient descent, we use the function 5 times x squared plus 3 times x minus 4. We performed the gradient descent in Excel, and you should have that file available. If you remember, we arbitrarily chose 4 as an initial value. In other words, we initialized a weight with a value of 4. The next occasion on which we stumbled upon initial weights was our simple example. Back then, we initialized them randomly in the range minus 0.1 to 0.1. If you haven't asked yourself this question, now is the time. Does it really matter what the initial weights are? Well, we wouldn't create a whole section about it if it didn't. In the minimal example, we said we will need random initial weights, but we didn't elaborate why. Okay, you can see the same scheme we used here for our backpropagation lessons. This is a model with a single hidden layer. Let's initialize our weights and biases in such a way that they are equal to a constant. It doesn't matter which constant. As you can see, the 3 hidden units are completely symmetrical with respect to the inputs. Each hidden unit is a function of one weight coming from x1 and one from x2. If all the weights are equal, there is no reason for the algorithm to learn that h1, h2, and h3 are different. Forward propagating, there is no reason for the algorithm to think that even our outputs are different. Based on this symmetry, backpropagating, all the weights are bound to be updated without distinguishing between the different nodes in the net. Some optimization would still take place, so it won't be the initial value. Still, the weights would remain useless. Alright, nice to know that. So, how are we supposed to initialize the weights then? We'll see this in our next lesson. Stay tuned.